Welcome to Education Lifeline. This is Trishita Paul, and today we will be solving quadratic word problems in Vertex form. This is the second video in our three-part series on quadratic word problems. But if you haven't watched our previous videos on quadratics, a playlist will be linked in the description below, as well as on the top right-hand corner of your screen. Please check those videos out before watching this one. So our problem states, you kick a soccer ball to your friend in gym class. The height of the ball, in meters above the ground, d meters traveled by the ball after kicking, is modeled by this equation. Now the first part asks, how many meters above the ground was the ball when it was kicked? Now whenever we are trying to solve any sort of word problem, we first need to identify what critical point the question is asking us to find. This may be the y-intercept, the x-intercepts, or the vertex, or any point along the parabola. Now here we can see that it's asking for the meters above the ground. And we have two options. It could either be d or h of d, and because it says meters above the ground, we know that it is the height of the ball, which is in meters above the ground. Now, to figure out what the height of the ball is, we need to know the distance, or the number of meters the ball was traveled after kicking. And that's given in the second part of our problem, when it says when the ball was kicked. That means that there's zero distance after the ball was kicked, because the ball is getting kicked right in the moment. That means we plug in 0 for d to find h of d, or the height of the ball, in meters above the ground. So that would be h of 0 is equal to negative 0.02 times 0 minus 10 squared plus 6. Now, 0 minus 10 is negative 10, and negative 10 squared is 100. So we have negative 0.02 times 100 plus 6. Now, negative 0.02 times 100 is just negative 2, plus that 6 will give us 4. So the ball was 4 meters above the ground when it was kicked. Now the second part asks us, at what distance from the player was the ball at its highest position? So here it's asking us to find the distance from the player, which is d. Now it's important to note that it's asking us for when the ball was at its highest position, which indicates that we're looking for the d value of the vertex. Here, we are given the equation in vertex form, which is convenient because we can look where the value of h is 10, which means that the ball was at its highest position 10 meters from the player. Now, the third part asks, what was the ball's maximum height about the ground? Maximum height indicates the height of the vertex, or h of d of the vertex, which you can find in this point right over here. Now, remember that the vertex is hk, where h is over here and k is over here. And since we're looking for the y value, or the height above the ground, this indicates the vertical shift. And that will mean it's 10 meters above the ground. Now, last part asks, if your friend was 40 meters away from you, would he or she be able to catch the ball? So this 40 meters away from you is indicating the distance traveled after the ball was kicking, or D. So we want to know the distance, if the distance was greater or larger than when the ball is going to be dropping to the ground or reaches the ground after kicking. And that means we're looking for the x-intercept. That would be our critical point that this question is asking for. So if we set h of d equals to 0, we can find when the ball reaches the ground and see if that is 40 meters away from where it was kicked. So we have 0 is equal to negative 0.02 d minus 10 squared plus 6. And we are solving this for d. So that means we can subtract 6 from both sides to get negative 6 is equal to negative 0.02 d minus 10 squared. Now, if we divide negative 6 by 0.02, we get 300. So 300 is equal to d minus 10 squared. Now we need to take the square root of both sides to get this square term out. We can leave it positive because we know any real life problem will stay in quadrant 1. And so d minus 10 is equal to the square root of 300. Now the square root of 300 can be simplified to 10 root 3. And if you add the 10 to both sides, get d is equal to 10 root 3 plus 10. Now, 10 square root of 3 is between 20 is less than 20, because we know that square root of 4 is 2. So it's less than 20 plus 10, which is less than 40, which means that the ball will reach the ground before in front of your friend, around approximately 10 meters in front of your friend, which means that your friend would not be able to catch the ball and you did not throw it far enough. And that is how you solve a quadratic word problem given the equation in Vertex form. If this video was helpful, please drop a like and subscribe to Education Lifeline. Be sure to watch our next video on solving quadratic word problems in standard form, and check the description for more helpful resources. We include tips as well as practice problems in the description of every video. And please make sure to leave any questions in the comments down below. Thanks for watching.